6164. The most frequent type of ground or surface-based temperature inversion is that produced by A. Terrestrial radiation on a clear, relatively still night. B. Warm air being lifted rapidly aloft in the vicinity of mountainous terrain. C. The movement of colder air under warm air or the movement of warm air over cold air. The correct answer is A. A ground or surface-based temperature inversion refers to a situation where the temperature increases with altitude near the Earth's surface instead of the usual decrease. It is characterized by a layer of warm air trapping cooler air beneath it. The most frequent type of ground-based temperature inversion is produced by terrestrial radiation on a clear, relatively still night. Here's how it occurs. During the day, the sun's radiation heats the Earth's surface. As the surface warms up, it emits long-wave radiation, terrestrial radiation, back into the atmosphere. On a clear night, with minimal cloud cover to trap heat, the Earth's surface rapidly cools down through the process of radiative cooling. As the surface cools, it transfers the cooling effect to the air in direct contact with it. The air in contact with the surface also cools down, leading to a cooler layer of air near the surface. However, above this cooler layer, there might be a layer of warmer air due to various factors like a residual warm layer from the daytime heating, the presence of warm air masses aloft, or advection of warmer air into the region. The warmer air above acts as a lid or cap, preventing the cooler air near the surface from mixing and rising. This results in a stable layer of air with temperature inversion, where the temperature increases with altitude instead of decreasing. This type of inversion is commonly observed on clear, relatively still nights because the absence of strong winds limits the vertical mixing of the air. The lack of wind allows the temperature stratification to persist, leading to the formation of a surface-based temperature inversion. In summary, the most frequent type of ground or surface-based temperature inversion is produced by terrestrial radiation on a clear, relatively still night. The rapid cooling of the Earth's surface during radiative cooling leads to a layer of cool air near the surface, while a layer of warmer air above acts as a cap, resulting in a stable temperature inversion. 6167. If the air temperature is plus 12 degrees C at an elevation of 1,250 feet and a standard, average, temperature lapse rate exists, what will be the approximate freezing level? A. 7,250 feet MSL. B. 5,250 feet MSL. C. 4,250 feet MSL. The correct answer is A. To determine the approximate freezing level, we need to consider the standard temperature lapse rate, which is approximately 2.0 degrees Celsius per 1,000 feet. Given that the air temperature is plus 12 degrees Celsius at an elevation of 1,250 feet, we can calculate the difference in temperature between the current elevation and the freezing level. To find the difference in temperature, we first need to determine the difference in elevation between the current altitude, 1,250 feet, and the freezing level. Since the lapse rate is 2.0 degrees Celsius per 1,000 feet, for every 1,000 feet increase in altitude, the temperature drops by approximately 2.0 degrees Celsius. So, the difference in elevation between the current altitude and the freezing level is 7,250 feet to 1,250 feet, equals 6,000 feet. Now, we can calculate the temperature difference by multiplying the lapse rate by the difference in elevation. Temperature difference equals 2.0 degrees Celsius / 1,000 feet times 6,000 feet equals 12 degrees Celsius. Since the initial temperature is plus 12 degrees Celsius, the freezing level occurs when the temperature drops to 0 degrees Celsius. To find the freezing level, we subtract the temperature difference from the initial temperature. Freezing level equals 12 degrees Celsius. 12 degrees Celsius equals 0 degrees Celsius. Therefore, the freezing level occurs when the air temperature reaches 0 degrees Celsius. Given that this temperature occurs at an elevation of 7,250 feet, which is the freezing level, 6,167 to 1, an increase in temperature with an increase in altitude? A. Is indication of an inversion. B. Denotes the beginning of the stratosphere. C. Means a cold front passage. The correct answer is A. Typically, temperature decreases as you ascend in the Earth's atmosphere, which is known as the normal lapse rate. However, in certain situations, an inversion occurs where the temperature increases with an increase in altitude instead of the expected decrease. This inverted temperature profile is characterized by a layer of warm air trapping cooler air beneath it. An increase in temperature with an increase in altitude is a clear indication of an inversion. It means that the normal lapse rate is reversed, and the temperature is rising as you move higher in the atmosphere. This inversion layer acts as a barrier, preventing the vertical mixing of air and can have significant effects on weather patterns and air quality. Inversions can occur due to various reasons, such as radiative cooling during clear, calm nights, subsidence of warm air aloft, or the presence of temperature inversions associated with fronts or stable atmospheric conditions. Inversions are commonly observed near the Earth's surface or at specific atmospheric levels, such as the tropopause. In summary, an increase in temperature with an increase in altitude is an indication of an inversion. It signifies a reversal of the normal lapse rate and the presence of a layer of warm air trapping cooler air below it. Inversions can have important implications for weather conditions and atmospheric stability. 6165. Which weather conditions should be expected beneath a low-level temperature inversion layer when the relative humidity is high? A. Light wind shear and poor visibility due to light rain. B. Smooth air and poor visibility due to fog, haze, or low clouds. C. Turbulent air and poor visibility due to fog, low stratus-type clouds, and showery precipitation. The correct answer is B. A temperature inversion refers to a situation where the temperature increases with altitude instead of the typical decrease. In the case of a low-level temperature inversion, a layer of warm air is trapped beneath a layer of cooler air. When the relative humidity is high, it means that the air is holding a significant amount of moisture. Under these conditions, the presence of a low-level temperature inversion can lead to specific weather conditions. The inversion layer acts as a cap, preventing the vertical mixing of air. It inhibits the rising of warm, moist air, which would normally result in the formation of clouds or precipitation. Instead, the moisture tends to condense and form fog, haze, or low clouds within or just beneath the inversion layer. Smooth air is also typically associated with temperature inversions. The inversion layer restricts vertical air movement and can create stable atmospheric conditions, resulting in reduced turbulence. Poor visibility is another characteristic of weather conditions beneath a low-level temperature inversion with high relative humidity. The presence of fog, haze, or low clouds can significantly reduce visibility, making it difficult to see distant objects or landmarks. In summary, when a low-level temperature inversion is present and the relative humidity is high, the most likely weather conditions beneath it are smooth air and poor visibility due to fog, haze, or low clouds. These conditions are a result of the inversion layer trapping moisture and limiting vertical air movement. 6168. An altimeter indicates 1,850 feet MSL when set to 30.18. What is the approximate pressure altitude? A. 1,590 feet. B. 1,824 feet. C. 2,110 feet. The correct answer is A. To determine the approximate pressure altitude, we need to apply the altimeter setting correction to the indicated altitude. The altimeter setting is the atmospheric pressure at mean sea level, MSL, adjusted for local conditions. It is provided in inches of mercury, in Hg, or millibars, MB. In this case, the altimeter is set to 30.18. To calculate the pressure altitude, we need to compare the altimeter setting with the standard atmospheric pressure at MSL, which is 29.92 in Hg or 1,013.2 MB. The difference between the altimeter setting and the standard pressure is used to calculate the correction. Difference equals altimeter setting. Standard pressure difference equals 30.18 in Hg. 29.92 in Hg difference equals 0.26 in Hg for every 1 in Hg of difference. We adjust the altitude by approximately 1,000 feet. Correction equals difference times 1,000 correction is equal to 0.26 times 1,000 correction equals 260 feet to find the pressure altitude. We subtract the correction from the indicated altitude. Pressure altitude equals indicated altitude. Correction pressure altitude equals 1,850 feet to 260 feet. Pressure altitude equals 1,590 feet. Therefore, the approximate pressure altitude is 1,590 feet.